Yes, it is the right time to apply the concepts that we studied about LCAO principle and its application to produce various molecular orbitals, their energetics. Let us begin our study with lithium molecule, Li2 molecule. Yes, lithium is a metal, but I am talking here about combination of only two lithium atoms. How will they combine? Which molecular orbitals will be there? What will be their energetics? What is its bond order? What is its magnetic property? Let us study.
Let us learn to construct the MO diagram for homonuclear diatomic lithium molecule, Li2 molecule. We will follow LCAO method to establish, to form, to generate molecular orbitals. Once we know molecular orbitals, their energies, then we can distribute electrons in those molecular orbitals. After distributing the electrons in those molecular orbitals, we can find bond order and magnetic property for lithium molecule. Let us begin. Which method of formation of molecular orbitals we will follow? LCAO method, which says us combining atomic orbitals should be of same energy. Combining atomic orbitals should be of same symmetry. Combining atomic orbitals should undergo appreciable overlap. All essential conditions are fulfilled by the orbitals which we are considering here in this MO diagram. Therefore, molecular orbitals are resulted. Then what about the orbital which I had not considered here? It is a part of the molecule. That's a 1s orbital from each lithium. Actually, lithium atomic number is 3 electronic configuration 1s2, 2s1, 2p0. So 1s orbital has 2 electron. 1s orbital wave function is there. So 1s orbital of one lithium wave and other lithium 1s orbital wave, they should interact. But they are not. Why? Is first condition not fulfilled? What is the first condition? Energies are same, so they should be interact. Second condition, symmetry. Symmetry also is same. S orbital both are. Then third condition, there should be appreciable overlap. Yes, that condition is not fulfilled. That 1s orbital is an inner orbital, is an inside orbital. So when the lithium molecule will establish, when two lithium atoms will come closer, at that time outer section, outer section, outer portion, outer orbitals, outer shell orbitals will interact, will mix, will interfere. But inner orbital will not undergo any kind of interference. No constructive, no destructive. Whatever the electron density, electron distribution is there in the 1s orbital, that will remain intact. That will remain as it is. Overlap integral capital S is equal to 0. What will be the name for those orbitals? Yes, non-bonding orbital. So 1s orbital from one lithium and 1s orbital from other lithium, they remain non-bonding. We represent them by a general alphabet used to represent first shell. What is alphabet? K. So K is a representation for one and K will be the representation for other. Now come to the second energy level. That's a 2s energy level. 2s orbital from each lithium. As per LCO method, they have the same energy, they have the same symmetry, and there is appreciable overlap because it's outer orbital. Therefore, they will interact. These two 2s orbitals will interact to produce equal number of molecular orbitals. Two molecular orbitals, one of them will be by addition, one of them will be by constructive interference, and that orbital called as bonding orbital. We represent it by sigma. Why are we representing sigma? Because see the symmetry of original orbitals. That's a 2s orbitals. If we consider internuclear axis and if I rotate the orbital around that internuclear axis, the everywhere there will be the positive or negative wave function, whatever the original wave function is there for that representative wave. It means there is no change in the wave function. It means it is symmetric about that cylindrical Z axis, internuclear axis. Therefore, we say it is sigma symmetric orbital. So sigma and sigma will interact to produce the other sigma orbital, that's a molecular orbital. It is generated from 2s orbital. So we are labeling sigma 2s. What about the antibonding orbital? We represent it by asterisk. So sigma star 2s is a name for antibonding molecular orbital. The energy with which sigma 2s decreases, with that much amount of energy, sigma star 2s will increase. I am talking from general chemistry point of view. True things are somewhat different. If you want to understand, you can go through the video making sense for MO diagram for nitrogen molecule. Their concepts of energetics will be the more clear. But at this second year level, I want that let you understand this equal amount of distribution, equal separation between the sigma 2s and sigma star 2s relative to atomic orbitals. So constructive interference has given us sigma 2s and destructive interference has given us sigma star 2s. Addition of wave functions give us bonding orbital sigma 2s. Subtraction of wave functions gave us antibonding orbital sigma star 2s. Now let us come to the further higher energy level, further higher orbitals. Those are 2p orbitals. Actually 2p is a subshell and orbitals are 2px, 2py, 2pz. So each 2p subshell is with 3 orbitals. Conventionally, we are considering Z as a internuclear axis, bonding axis. Pz orbital of one lithium atom and Pz orbital of other lithium atom, they will interact head on head. They will interact directly. They will interact axially to produce bonding orbital and antibonding orbital. Let us know the symmetry of Pz orbital. The Pz orbital is along the axis. If you rotate that Pz orbital along the axis, then there will be no change in the wave function throughout the complete rotation. Positive lobe will remain to positive side, negative lobe will remain to negative side. Since there is a no change, we are saying it is symmetric about internuclear axis, cylindrical axis. So what is the label for that? Sigma. So to Pz orbital from one lithium and to Pz orbital from other lithium, which has sigma symmetry, will interact to produce bonding sigma to Pz and anti-bonding sigma star to Pz orbital. But here somewhat energetics is different. The decrease of energy of bonding orbital is less than the increase of energy of anti-bonding molecular orbital. This we say as a low atomic number bearing element and its diatomic species. For that, the crossover is there. For that, sigma orbital, sigma to Pz orbital is of higher energy than that of the bonding pi orbital, than that of the pi sets. The main reason for that is the internal interaction between the sigma to Pz and the sigma 2s, as well as internal interaction between sigma star 2s and sigma star to Pz. To make this concept clear, you can again go through one other video, that's a making sense for MO diagram for nitrogen molecule. The sigma to Pz and sigma star to Pz interaction we understood. Think about the other 2p orbitals, which are those 2px and 2py. So 2px orbital from lithium will interact with 2px orbital of other lithium to produce bonding 2px and anti-bonding 2px. But what kind of symmetry that 2px orbital is with? Let us consider 2px orbital and rotate that 2px orbital around the cylindrical axis, around the internuclear Z axis. You will find one time positive lobe will come to negative, negative will go to the positive. So exchange of wave function will be there. So it is not symmetric for the complete rotation. So it means it is not sigma orbital. If not sigma, then what's the name of that? It's a pi. Yes, pi symmetric to px orbital from one will interact with 2px orbital of other to produce pi to px. Similarly, pi to py will be produced. And antibonding orbital pi star to px and pi star to py. The energies of pi to px and pi to py are same. So we say degenerate orbitals. And energies for antibonding molecular orbitals are also same. So bonding pi orbitals and antibonding pi orbitals are degenerate. Now question you will be with, here electrons are not there, then how wave functions will be there? If wave functions are not there, then how bonding and antibonding molecular orbitals will result? See, it is the energetics we are finding out. What are the possible ways of arrangement, possible ways of alignment, possible ways of energy levels in the molecule that we are finding out. So considering that possibility, we are considering outermost all orbitals. So 2s orbital we considered, accordingly we are considering the 2p orbital. Because excitation of electrons we need to consider, then energetics necessary. So what is the actual energetics in the molecule? To know that, we are considering those all interaction. So now in molecule of lithium, what are the energy levels? The lowest energy levels I represent first shell of one lithium as K. Afterwards, first shell of other lithium, that is K. Those are non-bonding, which are not shown in this MO diagram. Afterwards, sigma 2s, sigma star 2s, pi to px is equal to pi to py, sigma to pz, pi star to px is equal to pi star to py, and last sigma star to pz. Once these energetics of molecular orbitals we could understand, now we can distribute electrons in those molecular orbitals. How many electrons we do have in total in Li2 molecule? From one lithium 3 electron, other lithium 3 electron. So 3 plus 3 6. How can we put those electrons? I said lowest energy orbital will be filled first, then the highest energy, then the next energy level orbital. So which is the lowest energy orbital? Yes, it is a 1s or K shell. So K will occupy 2 electron and other K will occupy 2 electrons. So K will be the electronic configuration in non-bonding lowest orbital. So how many electrons are completed out of 6? 4. How many are left? 2. Where will they go? They will choose other higher orbital. Which is that? That's a sigma 2s. So both electrons will enter in that sigma 2s orbital. So what is the electronic configuration for lithium molecule? Kk, sigma 2s2, sigma star 2s0, pi to px is equal to pi to py0, sigma to pz0, pi star to px0, pi star to py0. Energies are same. And sigma star to pz0. If I have to find the bond order, what is the formula to find bond order? Bond order is equal to number of electrons in bonding orbital minus number of electrons in anti-bonding orbital divided by 2. How many electrons are there in bonding orbital? Only 2 electrons are there. Which is that bonding orbital? Sigma 2s. And how many electrons are there in anti-bonding orbital? No any anti-bonding orbital is with electron. So 0 is a number of electrons in anti-bonding orbitals. Substitute the value 2 minus 0 divided by 2. Answer is 1. Means in Li2 molecule there is a 1 bond as per molecular orbital treatment. How many unpaired electrons are there in molecular orbitals? 0. If 0 unpaired electron, then that will be diamagnetic in nature. It will not get attracted to the magnetic field. Other way, it will weakly repel the magnetic field. That is a diamagnetic behavior. So Li2 molecule, diatomic lithium molecule, will be diamagnetic. I am not talking about the lithium metal. I am talking about lithium diatomic molecule, Li2. It will be diamagnetic in nature. See the electronic configuration. I represented it separately. This can be the way of representation for electronic distribution for diatomic lithium molecule. See Li2, that's a diatomic molecule is represented. And in spite of equal to 3 horizontal lines are represented. Means is equivalent to or representation, equivalent representation. The lowest orbital, Kk, which are the non-bonding orbitals, represented by green color. And how many electrons are there in those non-bonding orbitals? 4. Afterwards, sigma 2s orbital, 2 electron. Sigma asterisk 2s orbital, 0 electron. But 0 is represented by yellow color. Why? Because the orbitals are anti-bonding. So electrons in bonding orbitals represented by white color, represented, and electrons in anti-bonding orbitals represented by yellow color. Then pi to px, 0 electron, is equal to pi to py, 0 electron. Means energy of pi to px and pi to py is same, therefore is equal to sign. Then sigma to pz, 0 electron. Pi star to px, see by yellow color, 0 electron, which has same energy, means is equal to pi star to py, 0 electrons, and comma sigma star to pz, 0 electrons. So equivalence of energy, degeneracy is represented by is equal to sign, and comma indicates the separation between the orbitals, energy level difference. So is this electronic configuration and application of molecular orbital theory to describe the diatomic lithium molecule clear? As a homework, you have two questions. First question, what is the bond order of diatomic lithium molecule? And second question, what is its magnetic property? We had discussion in this video. Only how to answer these two questions. The two-word answer in comment box.
So the application of molecular orbital theory to the lithium molecule might be clear to you. Let us study application of molecular orbital theory to next molecule, that's a Be2 molecule, whether it exists, not exist, magnetism. Let us see in the next part.